So I want to spend about 30 minutes just providing some background information and then move into an hour of activity that involves brainstorming, some sorting of ideas that you come up with, and then trying to characterize some concept that you come up with. Interesting. So I'm a professor at Carnegie Mellon University, and I'm a designer, but I sit in a computer science department. And I've been designing AI systems for about 25 years. This is the very first system I designed. It's for Philips. It was a TV show recommender back when Xena Warrior Princess was a first-run TV show. And it was a transition from like how many channels you had to a digital video recorder. So you were now going to have like 250,000 choices, and very quickly millions of choices. So how do we begin to think about organizing information more than just alphabetically? I've worked on a whole bunch of projects over the years. This is a system we built that detects the onset of major depression by notices changing in activity level, sleep, and social activity. Are you becoming less socially engaged? This was one of my favorite projects. We were kind of interested in, can we use technology to make parents feel like better parents? And parents generally feel bad about themselves as parents, so kind of make you go from crappy to slightly less crappy. So we made a system that learns where and when everyone in the family is, and we could learn the pickup and drop-off responsibilities of each parent. And then we could detect, when do you have a child that probably should be getting picked up, but no parent is moving towards that child. So it's like a smoke detector for forgetting your kids. Some of the current work that I'm doing, we are building smart classrooms that watch teachers teach and watch how students react to the teaching, and then providing feedback to help instructors sort of hyper-tune their performance. And I've done a bunch of work in healthcare, and this is generally a very high-risk decision-making space, which is a particularly difficult place to situate AI. And this was a system we developed for the helping clinicians decide when to implant a mechanical heart. So, a long set of my career really working, developing new AI products and services, but maybe 7 or 8 years ago, I really started to think about, like, how do we begin to engage with AI as a design material? I was very frustrated that pretty much everything AI that existed in the world was envisioned by someone with a PhD in machine learning. And while they're amazingly smart people, imagining things is not their strong suit. So how do we sort of open the door and really bring design thinking into what AI can do to transform the world? And then to ground the conversation, I just want to start off with, what do I mean when I say AI? And I mean everything from spam filters, like the most mundane thing we use that's been around for a long time, to systems that are trying to diagnose cancer by looking at medical images, mapping systems that tell us the best route in traffic, to new systems that are trying to do drug discovery by mapping between the chemistry of compounds to the physiological reaction of people's bodies. And what makes all of these things really the same from a design perspective is uncertainty. So when you're working on an AI project, you never know if you can build it, and you never know what errors it will make. And so it's this really uncomfortable space to be, because we've lost a lot of control that we typically have when making other things. Now, I'll start with the idea that AI is actually really amazing. This is an image of the Kiva robots. They're pretty good sized robots. They drive underneath shelves, they spin to get taller, and then they drive shelves around a warehouse. And the robots decide where everything goes. So unlike people, we would put all the red sweaters in one place. The robots put them everywhere. And the idea is a human picker is packing boxes, and every time they reach out the thing they need, that is right there. So it's super amazingly efficient. Amazon liked this so much, they bought the company and prevented them from using this technology anywhere else. So it's now exclusively Amazon Robotics. Another example I really like is smart pricing from Airbnb. So they're using machine learning to predict what's the maximum price you can charge and still rent your domestic space. And to me, this is like giving CEO business analytics to everybody, right? And to me, that's kind of a leveling feature, and I think that's a quality of AI. And then November, a little more than a year ago, ChatGPT came out. We had the rise of LLMs, foundation models, Gen AI, and this has been both frustrating but also transformative. And I would say collectively, this tremendous success implies that we have a really, really good innovation process. But we don't. Currently, about 85% of AI initiatives fail to deploy, right? They can't even get to the point of moving into the world. And of the ones that do deploy, about half of them fail. So our failure rate's way more than 90%. And so, being kind of pragmatic, I'm like, ooh, we could help. When things are this bad, maybe some design thinking can begin to be transformative. And there's 4 main reasons projects fail. One is that you just can't achieve model performance. You can never get the AI system to give you the quality that you need to create a viable service. There's a great example from Meta, giant company. They built an LLM that ingested a bunch of scientific papers, and then scientists could use it to ask questions. That is shut it down within 3 days because the quality of the answers was not valuable. It was actually harmful to science. Another big reason projects fail is they don't create enough value for the service provider. There's no way to get enough money back for the cost that you spend. You may be familiar with Amazon Alexa. That is losing $10 billion a year. $10 billion. Now, Amazon's a huge company, so we shouldn't feel sorry for them. But their entire economic model was based on the idea that people would shop, but no one shops on Alexa. What they do is say, hey, Alexa, play Spotify. So that digitizes the audio, which goes to an Amazon server, understands it. That just costs Amazon money, comes back, connects to Spotify. Now Spotify's making money and Amazon paid for it. There's not a lot of good thinking about the economics of it. Systems fail when they don't actually create value for users, so users simply don't use them. And almost everything I've seen in the healthcare space falls into this category. People keep making things, and clinicians are like, I don't need that. And so they don't use them. And finally, systems are really failing for ethical reasons, issues of fairness, data bias, privacy violations, or they create opportunities for bad actors to sort of do very bad things. So tremendous failure, but there's more than just failure. The problem's actually much larger. So my group looks at what we call missed low-hanging fruit. And this is opportunities where just a tiny bit of very simple, very easy AI would be great for customers and for service providers. So you may be familiar with Starbucks. Starbucks has a mobile app. The mobile app is a gift card model, which is awesome for Starbucks. So Starbucks gets money way before they give you coffee. In addition, the app reloads every 25 euros. So Starbucks avoids a bunch of credit card fees when you pay for your coffee with the app. But oddly, the Starbucks app never learns which customers pay for coffee with the app, and it never lands those customers on the Pay tab when they launch the app while inside of a Starbucks. Not a difficult inference to make, totally in line with what both customer and service provider wants, but a world-class UX team simply can't see that opportunity. It's not just Starbucks. Instagram, company you may have heard of. This is a meta company. This is a company full of the world's best data scientists and UX designers. Instagram really wants influencers to post because when influencers post, they attract people who consume ads that make money for Instagram. The Instagram app never learns which tags influencers always use, and it forces the influencers to type the same tags over and over again every time they post. Totally unnecessary, but like world-class teams simply can't see these sort of simple things. Another example that irritates me is self-parking cars. So BMW, Mercedes, a number of car companies are making cars that can park themselves. And this appeals to a tiny little audience of people that live in the suburbs and are afraid to drive in the city. And it's super difficult. So the car has to sense how big the space is. Then you have to tie into the acceleration, steering, transmission, and braking system. The car has to choose a policy, start to park, and then measure how it's activating on the policy and make constant adjustments. But if you look at the first step, it's like sense if the space is big enough. That could be on every car. Those sensors are already there. There's no cost. But car companies right now would rather do something that's hard compared to something that's valuable. And that's where we're trying to change things. So to help this make sense, I want to make a distinction between invention and innovation. So 1963, Philips invents the cassette recorder, right? This is a creation of a new capability to record and play back audio. Designers, really, our special action space is innovation. We recognize who needs that capability. I see people in the world and they could use this thing I know, and now I can wrap it in a product form where they experience it as useful and valuable. So we got boom boxes so kids could take music to the playground. We got Walkman so people could have a very personal music experience. And we got home answering machines so you didn't have to sit at home waiting for important calls, right? This kind of design innovation we do not see with AI, right? It's simply not happening, and it's very challenging for designers to get in there and work like this. I talk to tons of companies. What I hear everywhere I go is data science teams come up with ideas customers don't want. Design teams come up with ideas that can't be built. And so for us, this is like the innovation gap, and we really want to close it. How do we create the space where people conceive of AI products and services that people want and are easily buildable? And so my team's working under the assumption that almost all these projects are failing because teams choose the wrong thing to make. It's not a failure of AI, it's a failure of the innovation process. If any of you have studied data science, this is a typical data science process. It starts with problem formulation. If you read a data science book, that might get a paragraph, right? And it's all about how to build models. But data scientists aren't taught to ideate. They don't think of what are 100 things I could build. They just sort of like, oh, this seems interesting. Let's build this. In addition, design joins too late. In most cases, designers don't join until after the choice of what to build
has been made. So I've been designing interfaces for software since the very early 90s. That's how software was made then. People would come to us and say, hey, we have this thing no one wants. Can you make it pretty? And we called that putting lipstick on a pig. And it's interesting that AI has kind of returned to a process that we know doesn't work, but that's how most of it is developed today. But just bringing in designers doesn't help, because designers and really all non-data scientists think of AI as a superhuman intelligence, and this is very, very harmful in ideation. And I will blame the press, because the press loves these clickbait stories. Target knows teen is pregnant before parents. Artificial intelligence develops its own language. Google engineer says chatbot is sentient, right? None of these things are true. They're incredibly misleading, but they've created this sense that we should think of AI as a super intelligence. And so what happens is when designers or others begin to think, like, what can we do with AI? They tend to only consider things that are very difficult for humans to do, where you need nearly perfect model performance in order to be successful. And so the majority of the action space simply goes uninvestigated. IBM's been doing some great work in this space, looking at data science as a new discipline within the enterprise and looking at how it doesn't quite fit in. So most people think of data science as engineering, where you give them a spec and they make you a thing, but data scientists do not think of themselves as engineers. They think of themselves much more as explorers. They're looking for things that are interesting. And so there's a mismatch in expectation. The majority of the misunderstandings come around this idea of model performance, like how well will it work? So data scientists will say things like, we can achieve 90% model performance. And then they're like waiting for the applause, right? Is that good? That's like an A minus, right? That seems pretty good. If you think of automatic speech recognition, most sentences have around 14 words. That means, like, on average, more than one word in every sentence will be wrong. That does not seem good suddenly. You definitely do not want to be transcribing court cases with something that works like that, but it's perfectly awesome as a transcription of a voicemail. I get more than enough information to know what the message is about. Do I actually need to listen to it? What's the action I can take? So it's often thinking of the application space that's supportive of less than perfect model performance. Another big problem is that designers struggle to understand AI capabilities. And I make a distinction here between mechanisms and capabilities. So mechanisms are how, capabilities are what. Just because I'm a design professor, let's channel a little theory here. If you remember Donald Schoen's idea of reflection in action, he uses the metaphor of a jazz musician who knows their instrument so well they can create music while playing. And in that creative act, you have to have a really internalized understanding of the capability, so when you're brainstorming, that idea simply emerges. Currently, almost everything written about AI is mechanistic. It's about, we have supervised learning and unsupervised learning and reinforcement learning and pre-trained models, support vector machines, deep learning. It's all about how inferences are made. There's almost nothing on what can I do with AI. Another big problem is user-centered design does not work. And I've run into this problem like 1,000 times, and it took forever to be like, okay, we cannot keep doing this. And it doesn't work because you must start in the middle. Every project must start with the selection of what you're making. If you do user-centered design, you go and you like, oh, we're going to study these users, we're going to learn about their pain points. We're going to pick some priorities. These are the real problems. If we could fix these, that'd be awesome. The problem is that almost never aligns with what AI can do. Because you predetermined your solution must be AI, right? You've assigned a data science team. It's not really about solving someone's needs. It's looking for the harmonious intersection between needs and capability. And when you take a user-centered design approach, you turn your team into hammers looking for nails, and they apply AI to all the wrong problems. We don't privilege what it actually can do well. The last big problem I'll mention is that costs are tremendously opaque. Nobody knows what it's going to cost to build it. Nobody knows what it's going to cost to run it. And almost nobody asks how much money can it make. And this is a huge problem. If you go to an architect, you can say, I have $100 million. What can you build me? And they can tell you, like, you can get a building this size. We can use glass and concrete, steel, right? They can very much work with an amount of money and give you a sense of possibility. If you go to a data science team and say, I have $100 million, the only thing they can say with confidence is, we can spend that, right? This is very, very frustrating. So my team's been doing a lot of work to try to improve AI innovation. One of the first things we did was just hang out with people that do this well. So we hung out at places like Google, Meta, Philips, Accenture. And one of the things we noticed was that the places where it worked well, the data scientists and designers worked really closely together. Accenture's facility in Dublin was by far the best, where they sat next to each other and worked with each other every day. And the designers that were really good had internalized a bunch of abstractions of AI capabilities. And they had a lot of examples they could use to quickly communicate what that capability was, so both designers and data scientists understood. And so we really love this idea. So we spent 3 years building a taxonomy of AI capabilities. We looked across 14 industrial domains where AI was creating value. We looked only at things that were commercially successful and ignored all the research literature. And then we used a taxonomy building process to extract out 8 high-level capabilities. So AI can estimate, it can forecast, it can compare, it can detect and identify, it can discover, it can generate, and it can act. And this is, I'm not saying this is 100% coverage, but this is pretty good coverage of the space that you have to work in. And so we prepared some supportive materials that made it easy for designers to sort of quickly understand this, and then had them practice brainstorming to see, like, now we're going to get super amazing stuff. And it totally failed, right? It's like, we thought we'd cracked the problem, and we could definitely get designers to do a broader set of capabilities in their brainstorming, but everything they came up with was largely unbuildable. And so this sort of sent us in a different direction to really try to understand, like, what are we missing? And one of the things we encountered is this very cool analogy that comes from Google. So this is Casey Korzakov. She used to be the chief decision scientist at Google, and she taught an internal course called Making Friends with Machine Learning. And she's really trying to help teams find use cases where AI is actually valuable. And she used the analogy of AI as an island of drunk people. And AI is really fast, and it can handle an inhuman quantity of information because there's lots of drunk people. But they're drunk people. So don't expect it to be smart. So where do you need speed? Where do you need scale? But where do you not need intelligence or quality? And that is your sweet space. But it's like a really weird mental space to get into when you're trying to ideate new products and services. So to in an attempt to understand this better, we created a way of looking at ideas. We call this the performance expertise matrix. So on the vertical axis, we talk about task expertise, where the top level is like you need to be an expert. The middle level is like any adult human should be able to do this. And the bottom level is I could use less than an adult human to do this task. In terms of model performance, excellent is where you need well over 99%. Good is between 90 and 99, and moderate is where is less than 90% perfectly valuable for users. And we mapped our 40 AI features from our taxonomy on this, and what's fascinating was 25 of 40 all had moderate model performance. So they were all less than 90% accurate, but they were creating value for users and revenue for service providers. This was very insightful, but we needed a design process that helped us find when is like mediocre good, right? That's like a weird mental space to get into. So one of the groups that I collaborate with is a set of ICU clinicians and data scientists. They have this amazing data set that comes from 40 ICUs over 3 years. And we're thinking about how do we use AI to make things better and not kill someone. And so the first thing we did was to just hold brainstorming sessions. So none of these folks had ever brainstormed before. So it was really a question of can design facilitate brainstorming with people that don't fundamentally believe it's helpful. But they trusted us. We went through a process. We got them to generate a bunch of ideas. We mapped them using an impact effort matrix. What was a little frustrating was all of the ideas we came up with, almost all of them were going to be really hard to make, but only about half of them were valuable. And so we went back and we rethought what the method is. And so we did this again, but this time we primed people with examples of AI capabilities where you either had like very simple tasks or you had situations where moderate model performance was producing value. And we remapped what they produced, and now we were seeing a very different split. Now we were generating ideas that were impactful, but also going to be easy to develop. And that's what we were searching for. In addition, when we sort of mapped them on our task expertise design space, we were getting a lot better coverage when we did this pre-priming. So to just give you a sense of that, when we started, some of the ideas they were coming up with, the doctors were like, oh, can you help us with sedation? When you put a patient on a ventilator, you have to put a tube down their throat so they can breathe. It's super uncomfortable. So they sedate you. If they give you too much sedation, you developed delirium and you get PTSD and have lasting psychological harm. If they don't give you enough sedation, then you're anxious and in pain and it inhibits healing. Everybody reacts to sedation differently. They're like, yeah, can you help us with that? And it was like, absolutely not. We are not going to make things worse with AI. But interestingly, we talked to them about demand prediction. So this is where Amazon predetermines what people purchase. So they'll say, like, at Christmas time, we know people buy Christmas lights, so we pre-ship them to the warehouse. So when you order them, it only has a short distance to travel. The clinicians, interestingly for us, recognized that this idea was useful to them. They're like, hey, we order drugs from the pharmacy every day. It would be great if those patients got the drugs right away, but right now we wait 3 to 6 hours for them to show up. In addition, the nurses are way more efficient if they give all the drugs at once, and these nurses are super busy. As opposed to one at a time when they come from the pharmacy. What we could do is look at what's wrong with the people in the ICU today? What have we traditionally ordered for patients like this? Let's just pre-order those drugs. And if we're wrong, we just need to order drugs from the pharmacy, right? So it's the worst case is never worse than the current state, but the best case is an operational efficiency. And so for us, this is like what we're trying to find. We've been doing this with a bunch of companies, where it's like really a mixture of tech-centered and user-centered coming together, and we think of this as pre-agile. This is the work to figure out what to make before you commit the resources to make it, and we've been finding it quite successful. So I just want to throw out 5 quick takeaways that we can take into trying to brainstorm some AI concepts. One is, please don't replace an expert. Replace an intern, or better than even replacing an intern, look at a space where it's better than nothing, right? Like AI is amazing when you only need to be better than nothing. It can definitely do a bunch of stuff in that space because your willingness and the usefulness of mediocrity is actually pretty good. You want to be, when you're setting up an AI process, you want to be explicit about your innovation scale. So you might be familiar with McKinsey's 3 horizons model, like how far in the future are we looking? I prefer like a Google view. They talk about versioning. Are we just creating new features for an existing product that might be out in a few months? Are we visioning? So now we're thinking about something like a year to 2 years, so it's a major new feature. Or are we venturing? And if you're doing versioning, this is an awesome place for user experience design to have a big impact, to really think from the user's felt experience, what would be good. If you're doing the visioning and looking at that 1 to 2 year horizon, this is where I think service design's the most valuable. It's thinking much more strategically. It's really thinking about co-creation of value between users and the service. And if you're venturing and looking at like, what can I do in 5 years? There's no place for design because we have absolutely no idea what AI is going to do. So that really should be your technical team. Design's just going to slow things down. Design needs to play a different role. It's really not about designers coming up with the ideas. It's about design functioning as facilitation to bring in domain experts and data scientists and help them co-discover what they could make that's valuable and useful. And I want to move away from the idea that it's design-led. But design is an equal partner and is definitely required to make things work. The value of design is really to scaffold and enforce effective ideation, and to really make sure teams are investigating where moderate model performance is valuable, to kind of hold them accountable and to keep returning, and to make sure that you're generating ideas in that space. Some very recent work we've been doing shows a really strong correlation between when you come up with ideas where moderate model performance is valuable to users, you are almost never in a space where you have a responsible AI problem. So just looking there generally avoids some of the most difficult to solve problems with AI. Finally, we have an AI brainstorming kit that we put up online, and we encourage people to use it and to let us know if you find it helpful. So definitely want to make this available to people. So I just want to take a second to thank the groups that funded us to do this work: the National Science Foundation, National Institutes of Health, the Center for Machine Learning and Health at Carnegie Mellon, Accenture, and Bloomberg. They've been very supportive of this work, and they're encouraging us to kind of get out and talk to people that are in the weeds to pass this knowledge along and really help us get better at making AI things. So now I want to shift into workshop mode and to get you to try to ideate. And I want you, because we don't have time to do user research, just use yourself as a user, right? think through in your own life, is there something that AI could do that is valuable for you? And there's a PDF, and we're going to try to figure out how to get that to everybody. But I just want to kind of go through what's in the PDF. So we have the 8 capabilities, tells you what it is. So detect, this is like monitor, sense, notice, classify, discriminate, right? Detect and identify kind of go together. Identify is like very specific. So like I can detect if there's a face, because there are lots of things that aren't faces. But once I've detected a face, now I can identify whose face it is, right? So identify is like I have a set of similar things. How do I pull out specific ones? Estimate, forecast, and compare are all sort of a linear regression view. Estimate is current state. So like estimating driving time, estimating chances of something being true. Smart speakers use this to tell where sound is coming from and to kind of listen in a direction. Forecast is similar to estimate, but it's thinking about the future. Based on historic patterns, can I tell, like, when will my plane ticket be the cheapest? What's that absolute moment? Compare is more in the space of recommenders. This is kind of how most recommenders work, or things we think of as recommenders, where I have a set of things and I'm basically creating a ranked listing of them. If you think even Google search is fundamentally this. I think Google search is a great example of moderate performance that's valuable, right? Like the top item is almost never what you want, and they still give you a very valuable experience by giving you 10 things to choose from, where it's almost always in those top 10. And you can use your own intelligence to quickly determine which one you want. And it's like how design can negotiate like weak AI to make it valuable. Discover is about finding patterns in data, discovering things that we don't know are there. Web usage mining is one of these. It's like, so you can have a website and you think people are using it for this, but if you actually mine what people are doing, you can discover, oh, they're actually doing something else. And that's very much a discovery task. Generate, you guys may be very familiar with this. This is all the rage right now. So generating text, generating images. This has actually been used a lot in a really interesting way to generate medical records. So you can have a deep set of medical records, but actually preserve patient privacy. So it's synthetic data. And ACT is mostly reinforcement learning, but it's where you're selecting a strategy and then measuring your process and executing that strategy. So things like autonomously parking cars, agents that play poker, drones that fly. So this is all in the PDF. And then there's some examples of where AI is working. And so in the bottom corner, we've sort of put our expertise model performance matrix. And so you can kind of see for different areas on there, here's an example where AI is creating value in the world. All right. And then I want to use that to get you to generate ideas. Then the use impact effort matrix to start to sort your ideas, and then pick one idea and document. So maybe we can shift to the tables and start some ideation.
I want to be able to search an album by drawing.
I don't know if it's doable, but it should be.
This is a good idea.
ideas where we introduce this approach.
But does it need to be something that already exists?
Probably act differently.
Yeah, thanks for, if we can just gather back for a second. I just want to throw out some final thoughts to think about. Just kind of reinforce the point. AI projects fail at a ridiculously high rate, and they fail because we ask too much out of AI. And that there's a real opportunity for design if we can learn to ask less and recognize overlooked opportunities. I'm hoping you had the experience of seeing that that's actually not easy to do. We teach this as a full semester course, and typically it takes about 3 months before we get students that gain the sensitivity to recognize opportunities for dumb AI, but because we all want it to be what it's not. We want it to be smart, so I don't want you to be disappointed in yourselves. This is part of the struggle. But can you think about how you might bring this into what you're teaching to give students the opportunity to think about AI services and to try to sketch concepts where they would put AI in the world, but where you're demanding of them, it can't actually be very smart. We're really good at building systems that are less than 90% accurate. We are not good at anything else. Any final questions from you? I know we'll have some more time for reflection if anybody just wants clarification. Otherwise, I really want to thank you all for jumping in and trying. It's actually ridiculously hard. And hopefully a little bit of fun in the frustration. But thank you.